This is Group 6A's formal lab of a collision of a billiard ball with the carpeted wall. So the question that we're trying to answer with this formal lab is, how does changing the angle of incidence for the pool ball hitting the wall affect momentum conservation and the fraction of kinetic energy lost?
So to answer this, we made an experiment where we would change the angle from 45, 30, 60, and 90 degrees to determine how that would affect the momentum or kinetic energy.
In an ideal elastic collision, we'd expect the angle of incidence to be equal to the angle of reflection. This wasn't exactly true in this case because there was some energy lost and some momentum lost to the wall. We're considering the system the ball. And the momentum was mostly conserved for all of the angles, but there were some changes due to friction and the padding of the wall. And also as the angle approached 90, more and more kinetic energy was lost to the collision.
Experiment, we propped up a binder at exactly 7.5 inches or 19.1 centimeters, and we made sure to position it at that exact angle we want, which was 30, 45, 60, and 90 using a protractor. We also used a ruler to make sure that the distance of the ball traveled was the same every single time to keep our data consistent. And we used a tracker software to get our results after we recorded our video, and we considered the system to be the ball.
So the physics ideas behind this, we're able to determine that the angle of incidence does have some effect on the portion of kinetic energy lost in a real situation. And although this model isn't entirely elastic as it is a real model, some velocity is lost from the ball when it returns in the opposite direction after a collision with the wall. The wall was massive, so the energy or the velocity it gained isn't significant at all and you can't see it. The potential energy of the ball is also constant at the beginning and converted into kinetic energy at the bottom.
And this is the table for 90 degrees. On all of these tables, we outline the point at which the ball is hitting the wall. This is our data for 60 degrees, our graphs, and again, point at which it's hitting the wall, and 45. And we also have the same thing for 30. Calculations for 30 degrees, this is the x component. We used the initial velocity in the x direction and the final velocity in the x direction as the velocities just before and just after the collision with the wall. And we plugged those into this change in momentum or impulse equation to find that the change in momentum was negative 0.017 kilograms meters per second, and also the mass of the pool ball was 0.16 kilograms. We did the same thing for the y component to find the total impulse. The impulse was close to 0 for all of the x components and y components because the collision was close to being elastic and returned at a similar angle to the angle that it hit the wall at. As you can see, the impulse or momentum change for the x component of 90 degrees was higher, and this is because the 90-degree ball is hitting the wall perpendicularly, and so most of the momentum change is in that.
So this was the equation that we used to calculate our fraction of change in kinetic energy. So we used the kinetic energy equation, which is 1/2 mv squared. And since 1/2 and the m are scalar quantities, we canceled those out and we got v final squared minus v initial squared over v initial squared.
So we did this calculation for every angle, and
angle means that more kinetic energy is lost to the environment if we're considering the ball our system. And this is true because when the angle increases, the x component, or the component of the ball's motion that is perpendicular to the wall, so the x component of the velocity, is higher for the higher angles. And when the component of the ball's motion that's perpendicular to the wall is higher, that means that it's more by the ball, which causes more kinetic energy to be transferred out of the system.
Some sources of error that we discovered with our experiment was that the spin of the ball wasn't the exact same every single time we did the experiment, so that could have caused some error. And energy lost due to the friction of the carpet, and collision of the wall having a carpet could be affecting it rather than it just being a regular wall. And with the software, the axis placement, instead of having it at the collision point, we had it at where we dropped the ball from. That could change something. And not clicking on the ball at the exact middle position could cause VF to be greater than VI.
One case in which this happened was at 30 degrees. That fraction of KE is positive because the final velocity was higher than the initial velocity.